Let's do one more example. So we want the ion concentrations in pb3aso4, and we're going to start the same darn way. We have pb3aso4. Whoops, let's get that a little neater. pb3aso4, and there's two of those. This is solid, and it's going to dissociate in water. So a very small amount if we look at the size of that KSP. And we're going to have 3 pb. And then the challenge question I always have for you is, what are the charges on these ions? So hopefully you can get that on your own. Aqueous plus 2. Yeah, I'll do it in parentheses. SO4, and this guy then is 3 minus. Again, we start at 0, and we're going to gain some amount, 3x here, and over here we're going to gain 2x. Now let's write our KSP equation with our concentrations first. So PB, whoops, P, not B, so lead, Pb2 plus, and raised to the 3rd power, that coefficient there. And then we're going to come here, and our ASO4, 3 minus, and that one is raised to the power of 2. Now let's put in our x's. So we have 3x cubed times 2x squared. Cool. Let's simplify that out. So 27x cubed times 4x squared. And we get that KSP, so our 4.0 times 10 to the negative 36 equals 108 x to the 5th. So remember, with our exponents, we add when we're multiplying, so the exponents just get added together. So then our next step then is to take the fifth root of 4.0 times 10 to the negative 36 divided by 108. And when we crunch that out, we get x equals 3.26 times 10 to the negative 8. So that's x, but that doesn't give us our concentration of lead or acetate. So let's see. Pb2 plus then is going to equal 3 times our x value. So that is 9.79 times 10 to the negative 8. And our acetate, ASO4, 3 minus, is going to have a concentration of 2 times our x, which is 1.95 times 10 to the negative 7, 958, 10 to the negative 7. Cool. So again, let's go back and think about if we have dissociated all of this that will go into solution, then I start with some value of x here, and for 1 mole of this, for this ratio of this, I will get 3 times that value and 2 times that value. That's just the same as when I do something like, say, Ca2OH, right? So if I have 1 molar of Ca2OH, I'm actually producing twice that of my hydroxide because I get 2 hydroxides. So the same thing is happening here. So my molar concentration here, or molar solubility rather, is going to be X, pb3aso4 2 equals 3.26 times 10 to the negative 8 molar. And there you go. So even when it's more complicated or slightly uglier, oh, that eraser button is killing me. It is just doing it step by step, getting to your x values, right? And then solving for our KSPs, or using our KSP to get to our concentrations and getting to x. So I think if ever you're in doubt on what x is, that you need to remind yourself of something that you're more comfortable with, like calcium hydroxide. Because then you can see for yourself, okay, I am starting with some given amount x, and because there's 3 moles of this and 2 moles of this to my x itself, I end up with more on the other side. Okay?